Okay, here we are, kinesiology 230, chapter 16, aerobic training, presentation 2. We're talking about components of aerobic endurance training, and I got to get into this. This is a beefy presentation. So here we are in those three main sections in the chapter. We're now into components. That starts on page 426. As we look at this section that starts on 426, we're going to get through this part in this presentation, and the remainder will be in a series of other presentations to follow. Now, mode refers to what exercise activity will be performed. We know this, we've talked about this. The general public can choose from any number of different modes of exercise. Athletes need programming that will support what it is they're trying to accomplish in their specific sporting activity. The things that affect the mode of activity to be performed: is there equipment available? Is the conditioning level of the participant appropriate? Are they familiar with the exercise equipment that you're going to use? Are there physical limitations? Have they have any short-term or acute injuries, or they have any chronic conditions that might limit them from being able to perform the exercise? When you look at translation of skill, they talk about this in the book, but there's some translation of skill from running outside to running on a treadmill, or biking outside to riding on a stationary bike, but it's not going to be 100%, not ever, because of the controlled environment that you have inside in a fitness facility. It's unrealistic to think. So you have to do some things in terms of adapting the workloads on a treadmill or on a bike to better mimic or replicate what happens actually outside. But the thing that here is kind of key is personal preference. If your client doesn't like it, they ain't going to do it. So you got to be able to have a client who is okay with doing a particular type of exercise, otherwise they'll never get done. So they talk about how exercise intensity can be evaluated several different ways, and they talk about heart rate and perceived exertion. And programming has to be aligned with the client's ability of mind. We've already talked about that. The level of intensity can be increased throughout a training program, and as a byproduct of the adaptation process of the cardiovascular system, you'll have a greater ability to perform work at higher levels. And what will happen is your client will have an adaptation in the cardiovascular system, but they'll also have a greater exercise tolerance. So what was once uncomfortable to them, perhaps because they're not familiar with the discomfort, they're not familiar with the workout, but once they become familiar with a particular type of workout, then they have greater exercise tolerance, and that bias is removed and they can work harder. But what you find is they can work at higher work levels with a reduced level of HR, meaning their heart rate actually doesn't get to 85% at the workload you did week one. Where week one, it won't take much to have your clients work at a higher workload, because they're deconditioned. The body will adapt to the stressor that's placed upon it, and what it took to get your client to 80% week one will not be effective when you get to week number 4 because of that adaptation. So you end up having a case where you kind of have to constantly push the gas pedal with your clients. So heart rate reserve, and this is kind of quirky the way the book writes this out. It's the difference between maximal heart rate and resting heart rate. It's kind of the reserve amount between those two numbers. It's a mathematical equation. But the book notes, and this is where it's quirky, the book notes that this difference must be attained during an aerobic exercise session before improvements in the cardiovascular system are seen. The authors follow with, for apparently healthy adults, moderate to vigorous intensity of 40 to 89%. And just realize that should be an AN, not AND. I'll fix that. Now, I know this relates to a question in the quiz, but I'm uncertain if it accurately captures the process. It's inferred that a client must go through an exercise program that causes maximal heart rate thresholds to be reached to be able to calculate out heart rate reserve. And in some regards, I don't think that's the case. I mean, you look at that and you go, okay, can the person who's coming in to work out are deconditioned? They don't have experience. They won't have the strength or the tolerance to be able to push themselves to get to maximal effort. To expect them to do maximal effort when you first meet them is nonsense. So, as I said in the previous slide too, what is maximal effort today will not be maximal effort 4 weeks from now. Your clients will be conditioned. Remember this in terms of training and floating max. It holds true here as well. So if you look at this, your clients will have great potential here when we talk about theoretical absolute max, and I gave a couple different type of exercise scenarios, and it holds true here in the exercise realm of cardiovascular. When they first start out and they get on an exercise bike, they just won't have the ability nor the tolerance to be able to get to their theoretical absolute max to really push and get as many watts out of that bike or work at a high intensity. But as they get fitter and fitter and fitter, yeah, they sure can. And this is a graphical chart that I just kind of had in my head my entire career, and it holds true across all domains in fitness and wellness. You have this theoretical ability, and then you have the actual ability that you're always constantly kind of pushing your clients towards to try to get them to have results. Here comes the math. Ready? Target heart rate. Heart rate and VO2 are closely related. We know that the harder you push somebody in exercise, the heart rate increases with an increase in workload. The increase in workload necessitates an increase in oxygen consumption in our bodies. We already talked about the oxyhemoglobin dissociation curve and the 4 Hemis and all that stuff. And you look at heart rate as a way to evaluate exercise intensity, and they talk about the relationship between VO2 max, heart rate reserve, and also maximal heart rate. So when you look at this VO2 max, heart rate reserve, maximal heart rate, they put this chart in here, they put this table in. It's good. It's a little bit mooky to try to understand, but just realize that the closer and closer you get to theoretical or realistically 100% max, these numbers tighten up. So you go from 3730 to 57 to 9190 to 96 or 9089 to 95 in terms of a percentage, because what happens is the variability in the actual equations gets tighter and tighter and tighter and tighter and tighter. And when you get to 100%, 100% is 100% across the board. So it's a good chart. I like it. It kind of gives you the idea of the variability you see in the lower percentages when we start talking about heart rate in exercise, and the absoluteness that you see when you get into heart rate and exercise when you get to the higher percentages. So age predicted maximal heart rate, APMHR, is 220 minus your age. It's a real simple, quick and dirty equation. It's real easy to be able to calculate somebody's heart rate. And just know that if your client has like beta blockers, that suppresses their heart rate and that limits the heart rate response to exercise. Like I have a client, as hard as I'm working, he'll never get over 90 beats a minute because of his beta blockers. That's just the nature of that medication. Excuse me. So once you've calculated age predicted maximal heart rate, then you can come up with the actual percentage and the actual heart rate you want to work on based off of percentage. So we have a target heart range. You're going to use the calculated age predicted maximal heart rate, then multiply the range in your zones to obtain numbers of beats per minute. So like in our example over here to the right, you have age predicted maximal heart rate times exercise intensity gives us our target heart rate. So if we have 220 minus the age of a 40-year-old, that gives us 180 age predicted maximal heart rate. Our 180 times 80% gives us 144. Our 180 times 65% gives us 117. So if we wanted our 40-year-old client to work between 65 and 80% of their age predicted maximal heart rate, APMHR, they would work between 117 to 144 beats per minute. That's where the math comes in. When we get into calculating age predicted maximal heart rate, then we can start getting into heart rate reserve, the Carbonin formula. The HRR, heart rate reserve formula, requires a resting heart rate for the formula. The resting heart rate is subtracted from the age predicted maximal heart rate to calculate heart rate reserve. Heart rate reserve is multiplied by the workloads, and then the desired heart rate intensity that you have are added back into the equation. So it's kind of quirky where you have to, do two calculations to get there. But what you end up having is the formula is heart rate reserve is age predicted maximal heart rate minus resting heart rate. So 220 minus 40 gives us our age predicted maximal heart rate of 180. The resting heart rate is 70 beats per minute taken in the morning, right when they get up. And that gives us a heart rate reserve of 110. So we multiply our 110 by 65%, 80%, that gives us our 72 and 80. And you add back in the resting heart rate that you see here. So the equation requires you to use resting heart rate to come up with the reserve, the amount that your heart can beat, 70 beats a minute or 180 beats per minute, and you come up with a range that's 110. And that 70 is used here in this part of the equation as you add it back to your calculated number to give you 142 beats per minute at 65% or 158 beats per minute at 70%. In theory, what happens here is when a person is fitter, because they're fitter, that reserve becomes bigger, meaning their resting heart rate gets lower and lower and lower. And what ends up happening is you have a bigger reserve to draw from, as the book writes it out. And so that causes this, the heart rate reserve, instead of being 110 beats, perhaps it becomes 120 beats because the resting heart rate is 60. And you end up having a larger number here based off of the calculated number, 65% times 120, 80 times 120 gives you a higher number, which will give you a higher workload here. That's the theory. And you know, it kind of works in practice, and I've used Carvonin, it's okay. Usually what I'm stuck using is just simple, dirty 220 minus your age times the percent, because I'm in the moment and I have to work with my clients and I have to quickly calculate it out. And so they give you the side by side here if you want to freeze me and take a moment to look through this. I'm not going to belabor the point here. I just wanted to put this up here so you can see the two side by side. Excuse me. And with that, I'm going to jump into the next presentation.